So let's talk about equilibrium of force. This is the easiest topic in physics. So equilibrium of force is the what? What is the easiest topic in what in physics of force? So I will explain it to you thoroughly. So under equilibrium of force, I want you to understand the what is called principle of movement. Principle of what? Principle of movement. Let me first define movement for you. So movement is the product of a force acting at a point. You understand? Is the product of a force acting at a point and the perpendicular distance of the line of action from that point. Do you understand? So let's say this is the point now. Let's say this is the point now. Let's say this is the point. So let's say this is the force now. Let's say for instance now, let's say we have a door now. Let's say this is the force you're trying to apply to the door. Let's say you want to open it. Let's say this is the door now. You're not trying to open it with a force. You understand? So you have to what? Apply a force here. You understand? And this is this force, you apply a force here. You understand me? So the point at which you are trying to open, I mean the point at which you are applying the force is the point. Why this place is the line of action of the force, which is the perpendicular distance of the force. Do you understand? Perpendicular distance of the force. So our moment here will be what? Moment here will be force times distance. She understand my point now. She understand. So let's talk about the principle of movement. Now it is very simple. Once you understand this principle of movement, ṣé mi fẹ́ mọ bọ́yẹn spell principle mọ́? Okay, principle of movement, yeah. It states that the sum of clockwise direction is equals to the sum of anti-clockwise direction. That's it. So let me just say, let's take for instance now. I'm sorry, excuse me. Let's take for instance now. We have a pivot here. We have force here. Sorry, I'm sorry for interrupting with my sneeze. So let's say we have force one here. We have another force. Let's say we have force two here. We have force three here. So this place, when you look at the hand of our clock, are you seeing what I'm doing? You will notice that this place is the what? Is the clockwise direction. Why this place is the what? Anti-clockwise direction. As you can see, clockwise direction. Why this place is our what? Anti-clockwise direction. Hope you understand my point now. It's very simple. So this place, how will you determine where is the clockwise and the anti-clockwise direction? It is by looking at where the pivot is. This is the pivot. You understand? Where the pivot, which is the point, is being located. You can see pivot is parting ways between F3. This F3 is different place, while this F1 and F2 is different place. She understand me? So you can see it is pivot that is parting their way. She understand me? So the sum of this one here, the sum of the clockwise of anti-clockwise direction here, the same as the sum of clockwise direction that is here. I'm just trying to explain simple concepts for you so that you won't have problem when interpreting questions. She understand me? So that's it. That's it about this. So you can see principle of movement was movement is equals to sum of moment of clockwise of anti-clockwise direction is equals to sum of moment in clockwise direction. I'm just trying to give simple illustration. We are still going to Lamarck's theorem. We are going to parallelogram law. But for now, let's just talk about the principle of movement. Before we will still talk about principle of couple also. So as you can see, this is our so let's calculate the moment of anti-clockwise direction first. You can see this is the force. It is acting at a point, and this is the distance. You understand my point? Is the distance. So it will be F3 times D is equals to, as you can see, wọ́n wá bíbá ẹni òun náà ń kọ bí eléyìí náà ni wọ́n ń ṣe báyìí, you understand? So F3 times D, let's call this D3. You understand? So let's say this place is like this place will be D1. Let's say this place is D1, this place is D2. You understand? So we have to what? Calculate the moment of the sum of the moment of here. You understand? As you can see, is equals to F1 times this D1. F1 times what? D1 abi plus F2. As you can see, F2. So in this time around, it will not be F2 times D2. You understand? You have to what? Add the sum of this place to this place. You understand? As you can see, the horizontal distance, this force is acting. As you can see, this is the horizontal distance. It is addition of this one with this one. I hope you understand my point. It the distance it takes to act on these points is very longer than this place. So you know only apply this D2, you plus this one together. So F2 D1 plus D2. Do you understand me? So you have F3 D1 is equals to F1 D. So F3 D3 rather. F1 D1 plus F2 D1 plus D2. So you just open the bracket and you know how you do it now. So that's that about that. We are still going to solve questions. Just hold on, my guys. So one thing I want to tell you is that you may see in some question, you may see that they will tell you that a uniform meter rule. When you see a uniform meter rule in a question, always note that the mass of that uniform meter rule will always be located at the midpoint. So the midpoint is what? Is the center of the meter rule. Do you understand? So this is the mass. When it is uniform meter rule, please note it to meter rule. You know that the mass is always located at the what? At the center of the meter rule, and the length of a meter rule is what? 100. The length of a meter rule is what? 100 what? Centimeter. I mean the length, you. So if you have to split it into two, you see that this place is 50 centimeter, while this place is 50 centimeter. So hope you get that one now. So let's move to the cocoa, which is calculation. Let's start botany questions on physics. Thank you.